Hey ladies, this is a solution for problem number 9 from your linear programming homework. This is on page 176 of your textbook. And I just have had a few questions about it, so I want to go over this. In case we don't get to it in class, you can just watch this video. So the first thing, you got to read the problem and figure out what it is actually asking you. So in this particular question, it's asking you how many jars of salsa and how many jars of tomato sauce should we make? In order to maximize profit. So maximizing profit, that's our goal. So profit is going to be our objective function. And jars of each, so we're looking at jars of salsa and jars of tomato sauce, those are going to be our x and our y's. So I always start by identifying an x variable and a y variable. So x equals jars of tomato sauce number of jars of tomato sauce, and y equals number of jars of salsa. From there, now every constraint we write should be related to our jars of tomato sauce and jars of salsa. Okay, so the first part of the problem says we have 140 tomatoes. Okay, so 140 tomatoes, and a jar of tomato sauce requires 10 tomatoes, and a jar of salsa requires 5 tomatoes. So first we're going to write a constraint about our tomatoes, but related to our tomato sauce and salsa jars. Okay, so our first constraint, again, it's about tomatoes, but it's related to our jars of salsa and jars of tomato sauce. So if it takes 10 tomatoes for a jar of tomato sauce and 5 tomatoes for a jar of salsa, together, all of the tomatoes we use in both salsa and tomato sauce has to be less than or equal to 140. So our first constraint, 140 is greater than or equal to 10x plus 5y. And again, that's because we're using 10 tomatoes for a jar of tomato sauce and 5 for a jar of salsa. Our second constraint is going to be about onions. So let's look what it says about our onions. And it says we have 13 onions left over. And there's 1 onion for the tomato sauce and a quarter onion for salsa. So let's write a constraint now dealing with our onions. So we have 13 onions total. 13 has to be larger or equal to 1x plus 1/4 y. So that's saying the total onions we use for salsa and tomato sauce has to be less than or equal to 13. And then our last constraint, it says that we need to sell at least 3 times as many jars of tomato sauce as we do salsa. So our constraint here is going to be 3y, so 3 times the number of salsa has to equal x. So our x is 3 times as big as y. So if we sell 1 jar of salsa, we have to sell 3 jars of tomato sauce. lastly, think about whether or not you can have negative numbers. So our last constraint is our jars of salsa has to be greater than or equal to 0. Our jars of tomato sauce has to be greater than or equal to 0, and our jars of salsa also has to be greater than or equal to 0. Now, when you're graphing this, you can just use the first quadrant. You don't have to actually graph and shade those inequalities. X is greater than or equal to 0, y is greater than or equal to 0. Just use all positive numbers. So when you actually do it, this would be your x is greater than or equal to 0. This is your y is greater than or equal to 0. And just focus on the first quadrant. Okay, then we actually have to graph our inequalities. So I'll use orange for this one. I'll use purple for this one. And I'll use green for this one. Okay, so let's actually graph these inequalities. So for the first one, 140 is greater than or equal to 10x plus 5y in standard form. So I'm going to find my x and my y intercepts. And I'm going to use a scale of 2 here. And a scale of 1 here. Just so that I can actually fit everything on my graph. And it's not going to fit exactly perfectly, but it'll be pretty close. And if you want to rewrite these into standard form, or into point slope form, or into slope intercept form, go ahead. You can do that. The first one, if you rewrote it, it would be y is less than, actually I should rewrite this in orange. Okay, so the first one, you have y is less than or equal to negative 2x plus 28. The second one, if you rewrote this into slope intercept form, you have y is less than or equal to negative 4x plus 52. And the last one, if you rewrote that, you would get y is less than or equal to 1/3 x. Okay, so now it might be a little easier to graph. It doesn't matter if you use the intercepts or if you use the slope and the y-intercept. Whatever is easiest for you is fine. Okay, so the first one, negative 2x plus 28. So first I'm going to plot my y-intercept, and again I'm going by 2's. So here's my intercept. And then down to over 1. Okay, there's all my points. So here's my so there's what my first line looks like. And it's always y is less than or equal to. So if I took my highlighter, I'll use yellow. Here's my solution for that first inequality. All right, now my second one. Y is less than or equal to negative 4x plus 52. I'm not going to graph my y-intercept because that'll take me off my chart, but I can pick a couple points for y. So I'm going to pick 5 for y, for x rather. So when x is 5, so that's negative 20 plus 52, my y is 32. So here's 28, and here's 32. And then my slope is negative 4. So 2, 4 over 1. Oops, actually this is way wrong. I actually chose 5 for a point, so I need to plot it at 5. Okay, -2. And then my slope is -4. -4. And plot as few or as many points as you need to. Now, I'm not super concerned about this because it's y is less than or equal to this line. So when I shade it, I don't actually need all of this. I don't actually need all that extra stuff there. So I'm just going to highlight my solution part. And I'll use blue for that. So it's all of this stuff here. Okay, so the area where both of mine intersect is that green region. But I still have one more inequality to graph. And that's y is less than or equal to 1/3 x. So I got 0, 0. And then 1/3 x. So I'm going to choose 6 as my x. And I need to have 2 as my y. And then if I choose 12, that's really the point I'm looking for. Okay, and then it is y is less than or equal to 1/3. So let's see what other color highlighter can I use. Use orange. So now that dark green is my solution. So I need to pick my vertices. So here's 0, 0. Here's 12, 4, because again, remember your scale, 2, 4. Okay, and then my last one is 13, 0. So I'm going to use these vertices, and I'm going to plug it into my objective function, which I actually still have to write my objective function. So let's do that first. My objective function. So I'm trying to maximize profit. So my function is going to be related to profit. So how much do I make for a jar of salsa? How much do I make for a jar of tomato sauce? So 2x plus 1.5y equals profit. Then I'm going to take my vertices. 0, 0, 12, 4, and 13, 0. And I'm going to plug that into my objective function. So 2x plus 1.5 y is my profit, which is 0. And then 2x plus 1.5 y equals 24 plus 6, which is 30. And then my last one, 2x plus 1.5 y equals 26. So my largest profit is here, $30. And that's if I make 12 jars of tomato sauce and 4 jars of salsa. So my optimal solution is 12 jars of tomato sauce and 4 jars of salsa. Okay, so try it again, look at the work that you did, and you can reference this for other problems, story problems that we have. Again, it's kind of complicated. There's a lot of different things going on, but when you set your constraints, you always want to relate back to your X and your Y variables, whatever those are. In this case, it was jars of salsa or tomato sauce. Thanks, ladies.